We had this request of discussion on the use of a TAD in order to control anchorage while we are performing an intrusion of the anterior teeth through the use of a cantilever system. So, as I said, it is quite an interesting topic to discuss, focusing on its biomechanics. And it cannot be just answered with a couple of words or with a few lines on Facebook. So I just had to create this short video to give my analysis of the problem. We need to analyze and estimate the dental displacement that the reactive unit would have due to this mechanics and reaction force system that is delivered to the reactive unit. You can imagine that we have this force system. The force that you see here, it's has to be considered not the force that we apply to the anterior unit, but the activation force of the cantilever. And we start from this force because this is just the equivalent force system of what we have at center resistance of the reactive unit. So this is our reactive unit. Okay. Now, if we have this force system, because here we have the activation, and it could be 20 grams or 40 grams if we consider the two cantilevers activated in the same way. But it doesn't matter how much is the real amount of force, the quantity of the force. But what we know is that at the CR here, we will have this force and this moment with the moment of force of 20. This moment of force of 20 is given by distance between the line of action of the force here and the CR itself. So it's a rather high moment of force ratio. Considering this moment of force ratio, we can consider that we have a central rotation which is rather close to the CR. If there are no other factors, and actually there are normally because we have occlusion, but at the moment I will not consider them, we should imagine that having a central rotation here, well, this is the movement that we can expect. And if we have this movement, the red drawing will give you an idea of the expected movements. That what we have here as major displacement is this movement. So actually our problem when we have this kind of mechanics, and our problem, if a problem exists, of keeping the anchorage is the extrusion of the first premolar and this movement, which is, let's say, at 45 degrees in this direction, distal and vertical. Okay, so we have these two components, and it's very interesting to say that if you have a very stable occlusion here, that's the real, in my opinion, this is the best anchorage you can have, because here if you have these two inclined planes, let's imagine that here you have the lower molar, the lower premolar, and here you produce forces that are just against this displacement. And so I think that occlusive forces most of the time, if you have a very good intercuspation, if you have a good intercuspation, are enough to prevent any kind of loss of anchorage of this kind of for this kind of mechanics. So our question was, what happens if I if I use a TAD and in more or less in this area, and I connect uh, with a ligature, that could be a metal ligature, this point of the reactive unit. In order to understand what happens in these conditions, we have know something about the use of TADs as indirect anchorage, because here we are discussing of TADs as indirect anchorage. Remember that you can use TADs as direct anchorage, and this means that you apply the force directly to the TAD, or indirectly, this means that you are connecting somehow the TAD with the reactive unit in order to restrain its movement. So in this case, we are connecting the TAD through this metal ligature to the reactive unit. And so we can speak about indirect anchorage. One thing that is that has to be explained is that when we have an indirect anchorage, we can use this in three different ways. We can have a rigid connector, and the rigid connector can be a total block. In engineering, we call it strut, or a pin joint where we transfer forces, but we don't transfer moments, or a tie. The tie works effectively only when we have an elongation of it. That is, it transmits a tension force between the 2 points of ligature to the reactive unit and to the TAD. Otherwise, if the force is not applied to elongate the tie, what happens is that the tie works in a way as a hinge system. That is, the tie stays elongated and rotates around the 2 points of ligature. Personally, I would recommend every time you use a TAD as indirect anchorage to make a connection through a strut, so use a rigid connector and prevent any kind of and transfer any force from the reactive unit to the TAD. In this case, it was proposed to use a tie, and the tie has a lot of limitation that now we have to see. So the ties works only if we have this tie. We can imagine that we are connecting this point to this point, and we have this line here. And so it creates only a force in this direction here. Now you can understand that so the limit of using this TAD here is that we are creating something working only against pure vertical forces. But here the movement is in this direction. So what happens is that I create a vertical force here. I don't create a sagittal force here. And so no sagittal force is created here. And so I'm not really interfering with this movement very much. This is an anchorage which works, in my opinion, not as much as a good occlusion, definitely. And as a matter of fact, imagine that you don't have occlusion at all. What you would see is that you will have a force system that it's um, blocking the extrusion, but is not blocking this movement. Okay, so the total force system that you will have will be basically an intrusive force, which will be much higher than the extrusive force that you gave here. And what you will see, it's probably an intrusion in this area. I wouldn't say that this is a big problem normally, but that's the difference you are creating by using a TAD. Some other comments about the use of the TAD. I mean, I've been placing this TAD here because it was placed here in the example that was provided by our member, but basically cannot be applied so apical. So you will most probably place it here at this level, and this would be definitely better because if you have a tie with a TAD which is closer, so what happens that after a little distal displacement of this area, the tie will be like this, and we will also block the distal movement. So it's like having a lead. If you have a long lead, you leave a lot of freedom. If you have a short lead, the freedom is more limited. This happens to the dog and happens to the teeth as well. So if you really want to use a TAD with the tie, it's better that you try to have the tie as short as possible. And remember that anyway, it will only work if the tie with some limitation. So the tie doesn't do anything about contraction. So if you have this tie and you have a force like this, it's not going to help you. It only works against elongation, okay? So there are a lot of limits. My recommendation, if I want to use a TAD in order to block this movement, and I would do it only in a case, let's imagine that you have a patient that doesn't have teeth in this area. Okay, then in that case, I would say, well, I want to prevent problems here, or you have a patient which is extremely hyperdivergent, so high angle case, and you don't want to risk any increase of the vertical. So in these cases, occlusion could be not enough. And in these cases, I would use a TAD. But so let's speak how I would use a TAD, because this is the real point. First of all, I would never use a tie, but I will use a rigid connector. So a rigid connector means that you use a wire which has to be inserted in a slot here, and you bring it here, and you place some composite so that this connection here will transfer, is rigid, and will transfer any moment, any rotation of this point to the TAD. And this becomes a block, including the TAD, and we can expect a very good resistance against any kind of displacement. Nevertheless, even struts are perfect because you have some freedom of the wire in the slot, and the connector is not perfectly rigid. It has some elasticity. So it's always a good idea to have occlusion to help you. In cases that you have occlusion to help you, and you really need to have a perfect anchorage. So it's a case that is not very frequent, but it's okay. Well, I'd rather use a TAD not here, but in this area here or in this area here and block the motor. Because actually, the only movement that cannot be restrained by occlusion is the movement of intrusion. So this area can be controlled by the occlusive forces, this area cannot. When I see my patients with a good occlusion, the only thing I can imagine they can lose anchorage is lose contact in the most distal aspect of the reactive unit. So this is usually not a big deal. I mean, you lose a contact here, and that's it. After you have finished the intrusion of the anterior teeth, you will easily regain it. So, and I don't think there are many cases where this it's a real clinical problem. But let's imagine that you want to control it. So the best thing you can have is a good occlusion here and a TAD connected at this level or at this level. Okay. So I think that's it for my explanation of the problem. And I would say that all in all, this is something that you don't have to use so much in the clinic. So in 90% of the cases, uh, and even more, anchorage is not a problem when you are intruding the anterior teeth. Posterior anchorage is not a problem. And that's why I'm always a little bit, not very much convinced by all those um, mechanics that are shown sometime where you see TADs applied in the anterior and the use of TADs for intruding the anterior teeth. Well, it could have a meaning if for some reason you don't have a reactive unit. So, for example, you don't have teeth posteriorly, or you don't want to band or bond the posterior teeth. So in that case, it makes sense. But use a TAD here to make a segmental intrusion when you have bonded the posterior teeth. For me, it's really useless. I mean, it's not necessary. Sorry. It could be different if you are working on a continuous arch wire. In fact, if you have a TAD here and you apply a vertical force here, then you have a whole arch, and what you are trying to get, I'm not sure you can get it every time because it's a big unit, it's a rotation of the whole arch. So you are just changing the inclination of the occlusal plane. But personally, I'd rather use a segmental approach to this. That's another topic. Okay, so that's it, and thank you for your attention.